Good morning, children. We have been learning about the applications of quadratic equations in our day-to-day life since 2 to 3 days. Okay? Today, we will learn about the applications of quadratic equations related to right-angled triangle. Okay? Before we learn the applications of quadratic equations related to right angle triangle, let us understand what is a right angle triangle and its properties. Okay? A right angle triangle is a triangle in which one angle is 90 degree and the other two angles are acute. Okay? See here, one side is called base, another side is called height. Base and height involve in making right angle in a right angled triangle, whereas the other side called hypotenuse does not involve in making a right angle in a right angled triangle. There are two types of right angled triangles. Okay, they are scalene right angled triangles and isosceles right angled triangle. In scalene right angled triangle, base, height and hypotenuse, they are not equal to each other, but one angle is 90 degree and the other two angles are acute angles. All the three sides are not equal and all the three interior angles are also not equal here. Let us take this. This is a right angled triangle in which base BC and height AB are equal, whereas the hypotenuse AC is not equal to the length of base and height. So this is called isosceles right angled triangle. Okay, let us see in detail. Scalene right angle triangle, okay, here AB is not equal to BC, is not equal to AC. Okay, but in isosceles right angle triangle, AB is equal to BC, is not equal to AC, right? Then one angle is right angle and the other two are acute angles in scalene right angle triangle. In isosceles right angle triangle also, one angle is right angle and the other two are acute angles. Okay, then the side opposite to right angle is longest side and is called hypotenuse. Therefore, children, here 90 degree angle is B. The side opposite to right angle is AC. This AC is the longest side in right angle triangle and this is called the hypotenuse. Okay, here in isosceles triangle, angle B is the right angle. The side opposite to this right angle is AC. It is the longest compared to other two sides and this longest side is called hypotenuse. Okay, then the Pythagoras theorem is applied only to right angled triangles. According to Pythagoras, he says in any right angled triangle, the hypotenuse square is equal to height square plus base square. Okay, that is, in any right angle triangle, hypotenuse square is equal to base square plus height square. Here hypotenuse is AC, therefore AC square. Base is BC, therefore BC square. And height is AB, therefore it is AB square. Thus, a Pythagoras theorem can be applied to only right angled triangle in which the square on the hypotenuse is equal to the sum of the squares of other two sides, or hypotenuse square is equal to base square plus height square. Okay, and the same way we can apply Pythagoras theorem to isosceles triangle also. Here also the hypotenuse square AC square is equal to the sum of squares of AB square plus BC square, or height square plus base square. This is the pre-required knowledge to learn about the applications of quadratic equations related to the right angled triangle. If we learn this, then it will be much easier for us to go forward and learn the next concepts. Let us begin with an example. Question number 1. The sides of a right angled triangle are x minus 1 centimeter, comma x centimeter, comma x plus 1 centimeter. Then find the sides of the right angled triangle is the question. See here, in a triangle ABC, they have given the lengths of the right angled triangle as x minus 1 centimeter, x centimeter, and x plus 1 centimeter. Out of these three, x plus 1 is the longest side. That's why I take x plus 1 as the hypotenuse, as hypotenuse is the longest side in the right angle triangle. So if I make x minus 1 centimeter as base, then I make x as height. Okay, so ABC is the required right angle triangle in which x plus 1 is hypotenuse, x is height, and base is x minus 1 centimeter. I need to find the lengths of sides of this right angle triangle. So in the beginning, what I do is I apply Pythagoras theorem to right angle triangle ABC. Thus, this is AC square is equal to AB square plus BC square, or AB square plus BC square is equal to AC square by Pythagoras theorem. Okay, but AB is x square, plus BC is x minus 1, therefore BC square is x minus 1 the whole square, is equal to AC is x plus 1, therefore it is x plus 1 the whole square. Now you see children, x square is x square plus this is in the a minus b the whole square form. Therefore a square plus b square minus 2ab, right? But here it is x plus 1 the whole square is in the form of a plus b the whole square. Therefore it is a square plus b square plus 2ab, right? After the simplification, I have x square, 1 square is 1, this is 2x into 1 is 2x, right? This side, x square, 1 square is 1, this is minus 2x into 1 is minus 2x, right? Here, x square plus x square is 2x square, right? This is plus 1 minus 2x. I transpose this x square, this side becomes minus x square. Then this plus 1 comes as minus 1 and this plus 2x becomes minus 2x. Now you see, minus 1 and plus 1 get cancelled, and 2x square minus x square is 1x square, and this minus 2x is minus 4x is equal to 0. So 1x square minus 4x is the quadratic equation. Thus the statement is converted into a quadratic equation. Then by any one of the methods you can solve this quadratic equation for x. Now you see, I take x common and then remains x minus 4 inside, because x into x is x square, x into minus 4 is minus 4x. So children, here 1x square minus 4x has been factorized. So either x is equal to 0 or x minus 4 must be equal to 0. So if x is equal to 0, then x is equal to 0 only. If x minus 4 is equal to 0, x is equal to 4, or x is equal to 4 centimeter. So children, we got the value of x, which is the height of the right angle triangle. So the base BC is x minus 1. That is why I take AB is equal to x, that is 4 centimeter. BC is x minus 1, that is 4 minus 1 is equal to 3 centimeter. And the hypotenuse AC is equal to x plus 1 centimeter, that is 4 plus 1 is equal to 5 centimeter. Thus, the three sides of the given right angle triangle were found as this is 5 centimeter, 4 centimeter and 3 centimeter with the help of quadratic equation. Okay. Let us take another example. See here. The sides of a triangle containing a right angle are x minus 2 centimeter and x plus 2 centimeter. If the area of the triangle is 6 centimeter square, find its hypotenuse. Very interesting problem. See, this is the required right angle triangle. According to the statement, the sides involved in making right angle B are AB and BC. So, the lengths of these sides have been given as AB as x plus 2 centimeter and BC as x minus 2 centimeter. These two sides have involved or containing the right angle in right angle triangle ABC. But hypotenuse AC is not related to this. But we should find the length of hypotenuse in this triangle. But they have given the area of this right angle triangle ABC. So let us make use of the given data and find the length of hypotenuse AC. Okay, see here. Let the right angle triangle be ABC, right angled at B. And here AB is x plus 2 centimeter and BC is x minus 2 centimeter. And area of the triangle is 6 centimeter square. And AC is equal to hypotenuse. And what is the length of the hypotenuse? Okay. See here, children. We know that area of the triangle ABC is half into base into height. Okay. Area of the triangle is 6 centimeter square they have given. And this is half into base is x minus 2 into height is x plus 2 centimeter. Okay. Base is x minus 2. Height is x plus 2 centimeter. Now half into base into height. If this into 1 by 2 is transposed this way, it becomes into 2 by 1. Now it is 6 2s are 12 is equal to, it is x minus 2 into x plus 2 means a square minus b square. Therefore it is x square minus 2 square. X square minus 4. Here it is 12. If this 12 is brought this side, it becomes minus 12. Minus 12 minus 4 becomes minus 16. Thus 0 is equal to x square minus 16 or x square minus 16 is equal to 0. Thus x square is equal to 16. Then when the square is transposed this side, it becomes square root. Thus x is equal to square root of 16. Therefore children, x is equal to plus or minus 4 centimeter. Okay. Here, since the side of a triangle cannot be negative, therefore we take x is equal to 4 centimeter only and we omit or discard x is equal to minus 4 centimeter. So children, but we need to find the length of the hypotenuse. That's why the length of the hypotenuse is, okay. Let us apply the Pythagoras theorem to the given triangle. That is AB square plus BC square is equal to AC square by Pythagoras theorem. But here AB is x plus 2 the whole square plus BC is x minus 2 the whole square. AC I don't know. I have to find it. Now let the value of x be substituted. So x plus 2 means 4 plus 2 the whole square. 4 plus 2 is 6. 6 square becomes 36. X minus 2 is 4 minus 2. That is, it becomes 2. 2 square. 2 square is 4. Thus 36 plus 4 is equal to AC square, or 40 is equal to AC square, or AC square is equal to 40. And you see AC is equal to square root of 40. Now I factorize 40 as 4 into 4 into 10. But square root of 4 is plus or minus 2 and root 10 is a non-perfect square. That's why it remains inside as root 10 only. Thus the length of diagonal AC is plus or minus 2 root 10 centimeter. But the length of diagonal cannot be negative. So I take AC is equal to plus 2 root 10 centimeter. This is how we find the hypotenuse length cannot be negative. Therefore AC is equal to 2 root 10 centimeter is the length of the hypotenuse in the given right angle triangle. Okay. At last, let us take very interesting and one more problem. Here, in the adjacent side, a right angle triangle has been given whose hypotenuse is 2x minus 1 centimeter, base is x centimeter, and height is x plus 1 centimeter. We have been asked to find the lengths of the sides of a right angle triangle ABC. What to do? How to find? It is a statement problem. Look at the figure and do something mathematically and find the answer. See here, since it is a right angle triangle, we can apply Pythagoras theorem to this triangle. So, AB square is equal to BC square plus AC square. AB is 2x minus 1 the whole square. This is x square plus AC is x plus 1. That's why it is x plus 1 the whole square. This is in the form of A minus B the whole square, and this is in the form of A plus B the whole square. So, if we apply the identity here, it becomes A square plus B square minus 2AB, right? A square is 2x the whole square is 4x square, 1 square is 1, minus 2 into 2x plus 1 is minus 4x, right? Here, x square plus x plus 1 the whole square, x square plus this is a square plus b square plus 2ab, right? So children, x square plus x square is 2x square here, 1 square is 1, 2x into 1 is 2x. Okay, so 2x square plus 1 plus 2x is there, and let me transpose all these terms to this side. Therefore children, 4x square, if this 2x square is transposed this side, it becomes minus 2x square, minus 4x, right? And then this plus 2x comes, this side becomes minus 2x, plus 1, and this plus 1 is transposed, this side becomes minus 1, is equal to 0. Minus 1 plus 1 get cancelled, right? And here 4x square minus 2x square is 2x square. Minus 4x minus 2x is 6x. Therefore, 2x square minus 6x is equal to 0. See here children, this is the quadratic equation in x because the variable is x and here the variable's power is 1. Here variable power is 2. Therefore, the highest power of the variable is 2. That's why it is a quadratic equation in x, right? In both the terms, 2x is common. Therefore, 2x into x minus 3 is equal to 0 because 2x into x is 2x square, 2x into minus 3 is minus 6x. Therefore, I have factorized this quadratic equation as 2x into x minus 3. Okay, so 2x into x minus 3 is equal to 0 means either this is 0 or this is 0. If 2x is 0, then x is equal to 0 by 2, x is equal to 0. If x minus 3 is equal to 0, then x is equal to 3. Therefore, children, we got the value of x in this right angle triangle ABC. Okay, and this x is nothing but base of the triangle, right angle triangle. That's why base is 3 centimeter. Then what about the height and hypotenuse? Okay. Look at the figure. Here AB is 2x minus 1. AB is 2x minus 1. Therefore, it is 2 into 3 minus 1. 2 3s are 6. 6 minus 1 is equal to 5. Thus, the hypotenuse AB is 5 centimeter. BC is x. BC is x, which is base. The base is equal to 3 centimeter. And AC is height. AC is height, which is x plus 1 centimeter. Thus, it is 3 plus 1 centimeter is equal to 4 centimeter. So, we converted the quadratic statement into quadratic equation, then solved for x and found the lengths of the right angle triangle ABC. Okay. So children, today we learned about how the quadratic equations will help us to find the lengths of the right angle triangle in a right angle triangle. Hope you have understood this session, and the rest of the things we will see tomorrow. Till then, goodbye.